Okay, so we're beginning lesson 4. Review 4 is split up again, just like 7 was, into 2 parts. We have part A and part B. Then we're going to take a quiz on 4. Then we're going to do lesson 6, take a quiz on that, and then a big test on all of it together. So for today, we're looking at radicals and radicands and rational exponents. Our objective is to evaluate radicals, simplify radicals, expressions using product and quotient rules. So just a little bit of terminology. This symbol, the purple symbol, is called the radical. It's a radical sign, okay? The part underneath is the radicand. Does that start with a D? I'm trying to remember. It is with a D. Radicand. And the number here is an index. Now, for a square root, a regular square root, if there's no number written there, it's understood to be a 2. Sophia, close that, please. It's understood to be a 2, we just don't write it, okay? So, biggest rule, if the radical is even, meaning if my index, so let's put that up here. If the index is even and the radicand is negative, then there's no real solution. So I want you to think about, let's look at number 5, okay? Think about the ways to get 64. If I multiplied 8 times 8, I get 64, correct? What is negative 8 times negative 8? It's positive 64, right? So whenever we have an even, so this could be to the 4th root, the 6th root, an even number index, and a negative number is under it, we're going to say that there's no real solution. Later in the year, we're going to learn about imaginary numbers, but for now, we're just going to say no real solution for those. Okay, that's the only extra special trick to these. For the beginning of these, when we just have perfect squares, these are the easy ones. You're just going to use your calculator and take the square root of 576. Guys, if you focus and write down what I'm writing down, it's really going to help you on the next test. I'm sorry. Here you go. And yes, get your calculators out. Square root of 576, so this one is 24. Just like when we did absolute values, if my negative is on the outside, I leave it alone and do that last. So under the radical, I'm taking the square root of 81, which is 9, and the negative is on the outside, so it stays, let me put it on the side. So the negative stays there because it was outside of the radical. That's the difference between this one and this one. Square root of 1, what's the square root of 1? 1. For this one, we could separate it to square root of 25 over square root of 36, but it doesn't really matter. This is going to simplify to 5/6. So 5, because it was an even index and we have the square root of a negative, it's not real. For the cube roots in the calculator, the buttons that you press, the index is 3, so I start by pressing the 3. Then I'm going to hit that second button, and then the caret. It gives me a symbol that looks like this. So in the calculator, you should see 3, and then this. So it's the second button, then the caret, and then you get this. Then you type in the number. So this is what it should look like in the calculator. So this button is for any time your index is something other than 2. What is the cube root of 125? 5. Think about when you multiply cube roots of negatives. Also, if you try to take the square root of a negative in your calculator, it's going to give you an error. But because we can multiply, if I multiplied negative 7 times negative 7 times negative 7, these two would give me a positive 49 times the last negative 7 ends up giving me a negative answer of 343. Plus the calculator will do this one for you. So take the cube root, 3, caret, second caret. Make sure you use the negative sign down at the bottom in parentheses next to the decimal point and the equal sign. If you put minus, it'll give you an error. So it's the negative 343 and you get -7 is your answer. What about number 8? Very good. This is an even number. It's a negative. No real solution. Easy enough so far. I hope so. Because these are going to get a little complicated. Raise your hand if you need more time here. All right. For the next, we're going to look at 2 different rules, the product rule and the quotient rule. If I'm multiplying 2 things that have a square root symbol, I can just multiply them together and put them under one radical sign. Same with division. If I'm dividing 2 things, I can put them under one radical. That's kind of like that one we just had with the 25/36. These are the same thing. So for this one, I'm going to actually multiply the 2 times 8, which will give me 16. And now I can evaluate the square root of 16. That gives me 4.
Wait, I just did it like together.
I did it like 2 times.
Yeah, if you did that in the calculator just like you see it, it should have given you the right answer, yes? And y'all got 4? Awesome. Okay,
That's 7. 2 is 7.
say what?
2 is 7.
Okay, well, we're going to talk about 2. Just hang on for a minute. Okay. So there is a difference. If we tried to do the square root of 28 in our calculator, do the square root of 28 in your calculator and tell me what you get.
5.29.
It's about approximately 5.29. We are not allowed to use approximations. We need exact answers, but we need the radical to be simplified. So what I'm going to look for is my perfect square numbers. Will 4 go into 28? Yes, it does, 7 times. So I'm going to separate this. I'm going to separate this as 4 times 7. Now I can do the square root of 4. It's 2. If it helps you, you could write it as 2 separate ones as well. You can write it as 2 separate ones as well. But when I take the square root of 4, I get a 2, and I still have square root of 7 under the radical. So this is the simplified radical. To check your answer, type in the answer we got, 2 square root of 7, and it should also give you approximately the same decimal. So 2 square root of 7, I also get 5.29.
When I put 4 times 7 in there, I got the same thing as 5.
Yeah, I know. You would probably have to, yeah, it's, the calculator's gonna do that. The calculator will not simplify it for you. But we can only use the calculator for these to check ourselves. So you're gonna have to know your perfect squares, okay?
Oh, no.
I mean, I leave the list up there. All right, let's look at the next one. Look at my perfect squares. 4 doesn't go into 85. 9 doesn't go into 85. Does 16 go into 85?
Nah.
Does 25? 85?
More like that.
What about 36 or 49? None of them will go. So this one cannot be simplified. Okay. That 6 is on the outside. It's going to stay there. I'm going to look at the number 98. I want to see if any of these go into 98. So in my calculator, 98, I'm going to try divided by 4. That does not work. It gives me a decimal. 98 divided by 9 gives me a long decimal. 98 divided by 16, long decimal. 98 divided by 25, decimal. 98 divided by 36, decimal.
49.
Yeah. 98 divided by 49 is 2. So this becomes 49 times 2.
Doesn't matter what order it goes in.
So this is always gonna look
It doesn't matter, but at the end of the day, what you're ending up doing is you're separating it. which you don't have to write this step, only if it helps you. Because the square root of 49, I'm gonna take out and get a 7. Still have the square root of 2 there. And since the 6 was on the outside, remember that means multiplication. The simplified answer of this radical is 42 square root of 2. So, the calculator is good for trying to figure out what the square root is, but it's not going to be able to do the simplification for us.
Wait, I have to put it in the
So for the simple, we just look at that, right?
Yes, we're only looking for the perfect squares if it's the square root. These are problems that the more you do, the better, the more you practice, the easier it gets. Okay? All right. My -4 is on the outside. On the inside of my radical, look at my perfect squares. Which one's going to go into 75? It's going to be 25 times 3, right? So I leave my 4 alone. The square root of 25 is 5. What's left under the radical is 3.
And that's it?
Not quite. We have to still multiply. -20 square root of 3.
That one was
We can check all of these. If you type this in, you'll get a decimal. Type this in, it should be the same decimal.
So say like it was like cubed. We'll look at like the 1/8.
We're going to get to those. We'll get to those. 24x cubed. So now we're throwing a variable in there. Let's start with the 24. 4 will go into it, and that's 4 times 6. To take a square root, I need the exponent. If you think about it, the reason I can take the square root of 4 is because the square root 4 is equivalent to 2 squared. So when I take the square root, I get a 2 on the outside, right? So I'm going to separate my x cubed into x squared times x to the first. And I don't really need to write that 1. So the 4, I can take the square root. It's going to give me a 2. So that's taken care of. The square root of x squared is going to give me an x. I've taken care of that one. What is left under my radical is 6x.
We still gotta keep them.
Yeah, we still have some more. We got,
No, I ain't saying no.
oh no, that's it. We're done with that one, yes. This is our final answer for this one. Because 6 doesn't have any more perfect squares in it. Are we ready to move to the next? All right. This time we have a cube root. Okay? I can do, this one's easier actually because I can do the cube root of 125. That's it, that goes in evenly. But what I'm going to do is rewrite this as the x9. I'm going to write it as x cubed, x cubed, x cubed.
So that 3 is gonna stay outside?
Yes, I'm sorry, thank you. I need to have that there. So the cube root of -125 is -5, and I have 1, 2, 3 x cubes that I'm taking the cube root of.
Do you add them?
So I end up with x cubed. No, so what you're trying to think about on these, and this was as far as we got in the other class as well, what you're trying to think about is in order to take the cube root, I need it to be a cubed, right? And I have 3 of those. So I end up with 1, 2, 3 x's, x to the cube. The 5, -5 is the cube root of -125. Okay,
Wait, if you put that in the calculator, will you get that?
you'll get the -5 part, but that's it.
You're not,
You can't put the variables in. Not even Desmos. I can't even do this on Desmos. Okay? All right, that's as far as we're going today. The first like 6 or 7 homework problems you can try, but we're going to finish this on Tuesday and then work on the homework. And we still have last week's ACT to take this Tuesday. All right, product rule. If you're multiplying 2 things under a radical symbol, you just multiply them together. So I can put it as one radical. Same with division. So looking at this one, if I want to multiply the square root of 2 times the square root of 8, I get the square root of 16. The square root of 16 is 4. When you type this in the calculator just like that, it will give you the right answer. You just have to make sure that you close that parenthesis before you do the next square root. Now, the square root of 28 is not a perfect square. So in order to simplify it, we have to find a perfect square that goes into it. We're trying to factor it, we're separating it into factors, and we're looking for a factor that is a perfect square. So using the calculators, just go through your factors. Does 4 go into 28? Yes. So it is 4 times 7. 4, the square root of 4 is 2. So I can take that out of the radical. What's left behind is 7. How can we use the calculator to check this? If you type this in to your calculator, the square root of 28, you'll get a decimal. It's approximately 5.29. And if you type in what we simplified, 2 square root of 7, you get the same decimal. So you can still use the calculator to check it, but the simplifying, you are going to have to do some work. So the next one, 85. I don't like that color, it doesn't show it very well. 85, does 4 go into it? No. 9, no. Does 16? No. Does 25 go into it?
What is that?
No. What about 36?
I don't know.
What am I doing? I'm looking for perfect squares that will go into it so we can simplify it.
It's not real.
Okay.
Radical cannot be simplified.
Cannot be simplified. So because none of my perfect squares will go into it so that I could separate it, we're going to say that it can't be simplified. All right, that 6 is outside of there. I'm going to leave it outside of there, and I'm not going to worry about it until the end because order of operations, this is multiplication. I have to do the radical first. So I'm just going to leave that 6 hanging out down here. I'm looking just at the 98. I want to see the biggest number that is a perfect square that will go into it. So try some of these numbers.
49.
98, 49 will go into it. It is possible that you could have gotten a smaller one to go into it, but then when you would finish, you would still have a number under the radical that could be simplified more. So this would be, I'm separating this into the square root of 49 times 2. So now the square root of 49 is 7. I still have a 7 under my radical. So the 6 was hanging out there. 6 next to it means 6 times, right? So when I take this 7, when I take the square root of 49 and get a 7 on the outside, I'm just putting in parentheses so you can see that I need to multiply. And then I still have a 7 under here. Now I multiply this, 42 square root of 7. If you type that in and type this in, they're both the same decimal.
Why isn't 49 times 2?
So the purpose of simplifying, I'm looking for any number that's a perfect square, the biggest one I can find, that will go into what I started with.
Why do you have 7?
Yeah, I thought it was.
Oh, you're right, because my brain was already solving it.
That's what I was,
Thank you, Evan.
that's what I was confused about.
Thank you. I'm sorry, y'all. My brain was already thinking about square, you know what I mean?
So is it 40, I mean,
So it's 42 square root of 2.
That's what.
All right, this next one. I'm leaving my negative 4 out here.
Door.
And then I'm going to simplify. This is the notes from Friday. You were here, from Thursday. You were here for that. So see if you can find those. All right, for 75, I'm going to separate the 75 into 25 times 3. 25 is a perfect square. When I take the square root of 25, I get a 5. What's still under the radical is my 3. I can't forget about this -4 that was hanging out there in front. I need to multiply these two, which gives me a -20, and I still have square root of 3. That's my final answer. Close out. Focus over here. All right, start with the number. The number 24. Will 16 go into it? No. So it's going to have to be the 4. 4 times 6. For my variables, since I'm finding the square root, I want to see how many x squareds I would have. X cubed is x squared times x, right? Because when I multiply, I would add the exponents. So this is x cubed. I separated it into x squared times x. Because now I can take the square root of 4, which is 2. That's taken care of. The square root of x squared is x. That's taken care of. What's left underneath is 6x. That's my answer. Let's go to our next one. There we go. All right. It is a cube root, so it's okay that I have that negative there. Okay? The cube root of 125 is, negative 125, sorry, is -5, right? So I know that part's good. Now, x to the 9th, that part, think about it being x cubed, x cubed, x cubed, right? So I can take out 1, 2, 3 x's. We're going to get to a shortcut tomorrow or Thursday. Basically, what you have to do when you have a variable underneath, it has an exponent of 9, and whatever my index is, I divide it. That's how that x cubed will come out. I'm showing visually where it's coming from. We'll do more of this tomorrow. Today we're doing the visual, okay? I just want to show you that there is going to be an easier way that you don't have to write it all out all the time. All right, this next one. I'm leaving my 2 out here. I know don't want to forget my 2. For 81, I'm finding the cube root of 81. First, I want to see, is 81 a perfect cube? Cube root, 81
Yeah, no.
is not.
Oh, a cube.
Yes.
Square.
So now I need to see what cube roots will go into 81. 27 will go into 81. So I'm going to separate 81 as 27 times 3. My x to the 4th, I'm going to put in x cubed times x. My y to the 5th, I want a y to the 3rd, and what's left is y squared. Because these exponents add to what's there, these add to the y to the 5th. All right, I can take the cube root of 27, that is 3. I can take, so I got rid of that one. I can take out the cube root of x cubed is just x. The cube root of y cubed is y. I still have stuff underneath, a 3, an x, and a y squared. Last thing I need to do is this multiplication of these numbers. All right, the y to the 17th. I really don't want to write out a whole bunch of those y squareds, right? So I'm just gonna separate that as y to the 16th times y. We're actually gonna start that shortcut today. Here's in my index is 2, I'm taking the square root. It's kind of do you ever remember power of power rule?
No.
Power of power rule was, if I had 2 cubed to the 5th, I multiplied the exponents and got 2 to the 15th. We're doing the opposite of the power of power, and we're actually dividing our exponents is what we're doing. So 16, how many squares would be in 16? 16 divided by 2 is 8. So that comes out, and what's left underneath is just the y. So what I basically did was 16, I did this divided by the index. All right, yes.
Is that number on the outside? I can't tell by the way you're writing it. Is that y to the 8th and then square root of y? Or
Yes.
Y and then, okay.
We never change the root. So if it started as a square root, it stays a square root. Okay, first we multiply, then we simplify. 5 times 7 is 35. 3 times 15 is 45. X times x is x squared. Now, that's really ugly. It's a 2. Okay. I want to separate my 45 into 9 times 5 because 9 is a perfect square that goes into 45. Jasmine, close that. And I still have my x squared right here. I can take the square root of 9. That's going to give me a 3. I can take the square root of x squared. That gives me an x. So I dealt with the 9 and I dealt with the x squared already. All that's left underneath is that 5. 35 times 3 on the outside. I end up with 105x square root of 5. You can't do the variables, but number-wise, you could check this by typing in, and I don't want y'all to write this, but if you typed in 5 square root of 3 times 7 square root of 15, 5 square root of 3 times 7 square root of what? 15. Let's see what our decimal, our answer is. So it's 5 square root of 3, close it, times 7 square root of 15. I get the decimal 234. It's approximately 234.787. What we got for the number part was 105 square root of 5, right? Yeah. If I type that in here, 105 square root of 5, I get that same decimal. Okay? So we can check the numerical parts of it, but the variable parts, you just kind of have to know what you're doing. All right. Remember that division rule. I can put this under one radical and divide the 28 by 7, which would give me 4. Well, now it's easy. What's the square root of 4? 2. I'm going to put this under one radical, and I'm going to divide 560 by 5. That gives me 52. Dividing the variables. Remember our division rule
52 squared.
was that we subtracted.
Oh, but it's added.
We're subtracting. So what we're really doing here
So it's 52.
is x to the 5th minus a negative 3, which becomes a plus 3. So it's actually 52x to the 8th.
I'm confused. Right.
Where at? Hold
You
on.
said 561.5, right?
Yeah. Did I? Oh, I entered the wrong thing.
Oh, 'cause I got 112.
112. Thank y'all.
Oh,
My finger hit the wrong button. 112. Okay, so then it was the 5 divided by -3, I'm sorry, 5 minus -3 turns into a plus. 5 plus 3 is 8. All right. Addison Semino, this is really going to be easier if you stay awake and look. 112. I'm looking for my perfect squares. I want one that goes into 112.
112. Oh, yeah.
Underneath the radical, 112. So I'm just going to try some. I'm going to try some, maybe even a bigger one like 64. Nope. What about 36? Nope. What about 16? 7. So this is 16 times 7, and I still have my x to the 8.
Sorry.
Okay, so what's your question?
I was just, like, you divided.
I'm trying the perfect squares into 112.
112 by each perfect square. Okay.
And the reason, so because it's 112 and it ends with an even number, that's why I started out trying, you want the biggest one that works. So I started out like with the bigger even one, the next even one, this even one worked. Okay? Because if we'd have done 112 by 4, that would work, but then what's left underneath is 28, which could still be, take out another 4 from.
So I'll start with the bigger numbers.
So start with your bigger one. You want the biggest one. All right, so now the square root of 16 is 4. The square root of x to the 8. So it's basically 8 divided by 2 gives me x to the 4th. What's left underneath is 7. For that one? Mm-hmm. $13 is easier if we don't actually divide 49 by 144 because those are both perfect squares already. Yep, that's it for that one. For 14. Yeah. All right. I want to simplify this 5 over 80. So in the calculator, I can do 5 ABC 80, and it simplifies to 1 over 16. For my exponents, remember when you divide, you subtract them. So I'll end up with, at the top, p to the 4th. Are y'all with me on that one? So now the square root of, sorry, the square, it's going to still be a fraction. The square root of 1 is 1. The square root of p to the 4th is p squared. The square root of 16 is 4. If it helps you, you could have written this as the square root of p squared over the square root of 16. Sorry, this would have been a 4 here. My bad. And then gotten it that way, if it helps you to separate it.
So you were just simplifying over and over and over again until it can't be simplified over.
Yep. Is there more? That's it? Okay. The R4A homework, remember, do it in the Chromebook. But I do have your printed copies in case you have technical
So it's
difficulties.
just a lab day for us again?
The rest of today is a lab day.
Miss Alma,
Oh God, yeah, we'll do that. I have an ACT. Y'all are gonna hate me.
No, Miss Alma, for real.
No,
Not today. Can we take it?
Please,
No,
please not.
All right, y'all, but for this lab day, I need you, here's the thing with lab days. I give them to you, so when you choose to do a different work, I do expect you to actually go home and do the homework then.
Yeah, pretty much.
You know, because I feel like a lot of times people aren't, and then they're completely lost. Like when you don't practice something, you're going to not know how to do it. You know? It's like I used to know science. I didn't practice it and I forgot it all. So don't ask me to balance an equation right now. I don't know how
Well, it makes
anymore.
you feel better, I'm in science and I don't know. That's because you got me.
Yes, you did.
Does that have,
Better.
That you, yeah.
okay.
So some of you did start this homework last week, but remember I told you you could only get up to the first 7. No, I know. But now it might make more sense.